Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the idea of relation and function. Okay, so function here is the fundamental object in calculus itself, and the idea of functions come from the concept of relation. So in normal circumstances, relation means that two or more things have something in common. So for example, in a simple scenario, we can say that a brother and a sister are related because they have the same parents. So in mathematics, a relation is defined as a set of ordered pairs in the form of x and y. So this is the first element here. So x is the first element and it is known as independent variable. And y here is the second element and it is known as the dependent variable. So the order has to be independent and then dependent. So x and y, we call it ordered pairs. Now, the types of relation between two sets, so you have two different sets. You can imagine having two different sets here. So there are elements in this set and elements in the second set. So these two sets here have different types of relation, can have different types of relation. For example, it can have a one-to-one relation. As an example, one-to-one relation will be, if you talk about a simple scenario, it will be wife and hubby and husband. And the two sets here can also have a relation that is many to one. So it can be wives and husband, and it can also have a relation of one to many, for example, mother and children, and relation many to many. Well, you can think of it of an example on your own, I'm sure of that. So these are the four types of relation: one to one, many to one to many, and many to many. So the relation between two sets here can be easily represented using a simple technique called mapping. So we're going to look at some examples with regards to mapping here on the next page. Okay, so these are the idea of mapping. You have two sets and you map one set to another set here. Okay, as an example here, we can have, for example, in a particular class, these are the name of the students, and maybe these students are asked of what is their shoe size. So, for example, Stephen here has a size of 5, and similarly, Bruce here also has a size of 5. So this is an example of a relationship that is many to one. Okay, so two people can have one or similar shoe size. Okay, next, if you look at this example, this is passengers, the name of passengers and their boarding pass. So each person has one boarding pass, so one to one. So this is an example of one to one relation. Okay, for this one, you can see that these books can be borrowed, the same book title can be borrowed by these two students here. And similarly, for example, this particular student can borrow two different books. Okay, so this is an example of many to many. And a final example here is, this is the flight, a specific flight SG108. You can have one flight attendant, and this particular flight, for example, it can require two flight attendants. So this is an example of one to many. So one flight, many flight attendants. Okay, so here, there you go, many to one, many to many, one to one, one to many. Okay, now a function is a special type of relation. So function here is a special type of relation. So what kind of type of relation we are talking about? Basically, when you have a function f here, so f here is a rule. We can view that as a rule that assigns to each element x. So it assigns each element x. So we call that x is the independent variable. So it assigns each element x to exactly one element in set B. So x is the independent variable and fx here is the dependent variable. Sometimes you can also change the notation. You can represent fx simply as y. So this is also a common notation. Fx is equal to y, and f here represents the function, and x and y represents the input and the output. Now another common notation that is used to describe a function is this one. So this is another common notation. So f here represents the function, x is the input, or x is the independent variable that is mapped onto y here. Okay, so based on the definition above, can you determine which one of the following relationship defines a function? Alright, so let's look at this relationship. This is obviously a one-to-one. And because of that, this is a function. Why it is a function? Because again, we have to look at the definition here. A function is a rule that assigns each element of x. So this is all your x. This is also x. And this is also x. This is also x. Okay, x is the independent variable. So it assigns each element of x to fx in set B. Okay, so fx is actually y. So this is y, and this is y, and this is y, and this is y. So it assigns each element of x in a set A exactly one element. The keyword here is exactly one. So for this one, this is a relation of one to many, and because of that, this is not a function because it has more than one element in set B here. So it has more than one element. Next, for this one, this is many to many. So this is many to many, and this is also not a function. And finally, this is many to 1. So many to specific value. For example, 2 will be assigned to 4, negative 2 will also be assigned to 4, and so each element of x is assigned to exactly one element. So 2 with 4, one element, negative 2 to 4, one element, 3 to 9, this is one element, negative 3 and 9 is also exactly one element. So this is a function. Okay, so as a conclusion, we can say that function is a special type of relation where the relations are exactly one-to-one and many-to-one. Alright, that's all for now. Thank you very much for watching.